Hello everyone. In this video, we'll learn about testing for cations, which means that if you have a solution of the compound XY, where X is the cation and Y is the anion. So we don't talk about anions here. We will talk about cations. This means that we need to detect which cation is present in this solution. Okay, we will now talk about anion present that we've talked about in separate video for test for anions. This is the testing for cations. So how to find out which cation is present in the given solution? You have total 8 cations in your syllabus, out of which 7 we will be covering now. These cations are metal cations. The eighth cation is a non-metal cation, which is ammonium. So these are the eight, there are 7 cations, metal cations, whose detection you should know in your syllabus. Out of 7, 3 are non-transition metal ions, which is calcium, aluminum, and zinc. 4 are transition metal ions, which are Cr3 plus, chromium 3 plus, Fe2 plus, Fe3 plus, and Cu2 plus. This is 7 ions that you have in your syllabus, whose detection you should know. So detection के लिए you just need to, it's a one step uh, reaction that works for all. You simply add dilute sodium hydroxide. Okay. So what happens is when you add sodium hydroxide, the hydroxide in that will combine with the cation, whichever cation it is. So suppose if this cation is zinc, then the hydroxide added will combine with the zinc ion and you'll get zinc hydroxide. If this cation is calcium, then you'll get calcium hydroxide. If this cation is Fe2 plus, then you get Fe iron 2 hydroxide, and so on. So depending on which cation is present here, I will get any of these metal hydroxides there. One thing you should know that all these metal hydroxides are insoluble in water. Hence, they will form a precipitate. They will form a solid precipitate in the reaction. Now, you should just watch the color of the precipitate, because if any of the non-transition metal ions is present in this, then the precipitate will be calcium hydroxide, zinc hydroxide, aluminum hydroxide, which is white in color. So if I see a white precipitate here, which means I understand that it's any of the calcium or zinc or aluminum, calcium ion Ca2 plus, Al3 plus, or Zn2 plus is present here if I get a white precipitate. If I don't get a white precipitate, if I get a colored precipitate, then depending on the color. If you get a green colored precipitate, then the possibility is that it's either Cr3 plus or Fe2 plus. Okay, so there's a clash here. We'll see how to resolve this clash later. If it's a red brown precipitate, then the ion present has to be Fe3 plus, because the precipitate is iron 3 hydroxide, which is red brown colored insoluble substance. These are the colors given of all these hydroxide which are insoluble. If you get a blue precipitate, that means copper hydroxide is formed, and that means the cation present must be Cu2 plus. So all you need to do is that add add sodium hydroxide to the solution and watch for the color of the precipitate. So if it's a white precipitate, then any of these three: green precipitate, then chromium and iron; red brown precipitate, then Fe3 plus; blue precipitate, then Cu2 plus. Okay, this is what you need to do. Okay, now what about the clash? Like suppose if there is a white precipitate, then it could be any of the 3 cations, because whichever is present here would have combined with the hydroxide and would have formed any of these compounds. So, but I don't know which compound that is. So you need a further testing. Need to test this further. Further testing may all you have to do is that add more sodium hydroxide. Okay, you have already added sodium hydroxide to obtain a precipitate. Now you will add more sodium hydroxide. This is called as excess sodium hydroxide. So first you add few drops of sodium hydroxide, and then you'll get a precipitate of the respective color. Once you get the precipitate, then you add more of sodium hydroxide. Anyway, what will happen when you add more of sodium hydroxide? We'll see that in some time. This is the general equation for all the reactions that are happening. This is the compound XY. I need to know which is the cation here, X. I add sodium hydroxide. Sodium hydroxide will combine with that X to form X hydroxide, which is insoluble. We don't care about this. So we just need to see the color of this precipitate to decide which cation is present. Okay. So now we'll see the what happens when you add excess of sodium hydroxide. Okay, so we have seen that to test for a cation, you add sodium hydroxide, and depending upon which cation is present here, this hydroxide, added hydroxide combined with the cation form X hydroxide. So depending on which cation it is there out of this, you'll get a precipitate. So if calcium, aluminum, zinc, which are non-transition metals, present, so uh, precipitate color will be white for all the three. Chromium and Fe2 plus will be green precipitate, and 3 plus will be red brown, and copper 2 plus will give you blue precipitant. So to resolve the clashes here and here, we need to add excess of sodium hydroxide. What happens when you add excess of sodium hydroxide? The purpose of adding sodium hydroxide is to check if any of these precipitates will dissolve when you add excess of sodium hydroxide. The purpose is to check if any of these precipitate form, like this precipitate form here, is it dissolving? Okay. So we just need to check that if when you add excess of sodium hydroxide. So how do you remember that? Just remember that the aluminum, zinc, and chromium, these three, as we have learned in acid base chapter, that these three oxides and hydroxides are amphoteric, which means that their hydroxides will react with acid as well as base. So this white precipitate and the green precipitate, they're nothing but aluminum hydroxide, zinc hydroxide, and chromium hydroxide. So those hydroxide can react with a base, which is sodium hydroxide that I'm adding here. Okay, excess of sodium hydroxide that I'm adding here. Which means that these three will dissolve. The precipitate will dissolve here, but for others, the precipitate will not dissolve because they are not amphoteric, they are basic, and basic hydroxides don't react with bases. Okay. So, observation, when you add excess of sodium hydroxide to aluminum ion, the precipitate will dissolve, which means that you will get a solution like this. This is precipitate will dissolve if you add excess of any which thing. So here you will have to write precipitate. This dissolves. Now, whenever there is a precipitate dissolving, which means that it is forming a solution because it dissolved. So you also need to mention the color of the solution. So remember that color of the solution will carry 1 mark. So when a white solids dissolve, they form colorless solution. So in case of aluminum and zinc, you need to write precipitate dissolves to form colorless solution. So these 2 points should be there. Precipitate dissolves in excess and forms colorless solution. So mention the color of the solution also. When the green colored precipitate of chromium 3 hydroxide dissolves, it will form green solution. So do mention the color of the solution also. For others, simply precipitate does not dissolve. For all these three also, precipitate does not dissolve. Only these three dissolve because they are amphoteric in nature. Okay, so that's how you add excess and resolve two at least clashes. One is that between Fe3 plus, Fe2 plus and Cr3 plus. Cr3 plus, both of them give green precipitate, but when you add excess, Cr3 plus will dissolve, giving a green solution, and Fe2 plus का precipitate will not dissolve. Okay, so that's how the green का clash is resolved. Here in the white का, at least we can distinguish calcium from the other two, because if the in excess if precipitate does not dissolve, which means it's calcium. If the precipitate dissolves, then again there is a clash between aluminium and zinc. It could be any of the two. How do you resolve that? For that, you need to take a different reagent. So here I had taken aqueous sodium hydroxide. We'll need to take another reagent, which is there in your syllabus, aqueous ammonia. Okay. Here again, we need to know the test or observation when I add aqueous ammonia, few drops, as well as when I add in excess. So same as sodium hydroxide, you need to know the colors or the observations when you add few drops of NaOH, as well as when you add excess of NaOH. So in aqueous ammonia also you need to know the same. So in this aqueous ammonia में, let's see what is the observation for each of the ion and how it is different in sodium hydroxide compared to ammonia, or how is it different in ammonia compared to sodium hydroxide. So remember that for each one, how a particular cation behaves in sodium hydroxide, few drops and excess, how will it behave in aqueous ammonia, few drops and in excess. Okay, so first we will see few drops in all. So in aqueous ammonia, calcium ion does not form a precipitate. Or in some cases, it says very, very slight precipitates, but you can safely say no precipitate. Okay. Aluminium and zinc continue to give you white precipitate. Yeah. Chromium and Fe2 plus continue to give you green precipitate. Rest everybody's precipitate color is same. Only calcium will not form a precipitate. Rest everything is same for other cations when you add few drops of aqueous ammonia. Okay, so this will give you a blue precipitate. Here you should write pale blue. Okay, for a reason, we'll see that soon. Now what happens in the excess? Now because calcium has not formed any precipitate, so there is no need to add excess to check whether the precipitate dissolved or not. The precipitate was never formed. In case of aluminium and zinc, this time zinc, sorry, aluminium precipitate will dissolve. Sorry, will not dissolve. Sorry. So aluminium precipitate will not dissolve. So aluminum changed its behavior in aqueous ammonia. But zinc will continue to show the same behavior. Precipitate dissolves and forms a colorless solution. Chromium का green precipitate dissolved previously. This time precipitate does not dissolve. Iron 2 and 3, same precipitate does not dissolve. Same as they behaved in the sodium hydroxide. Copper this time in ammonia will form a it will dissolve a precipitate and it will form a dark blue solution. So I should actually change the color here. I use pale blue for the dark and dark blue for the pale. So in few drops, copper ions in ammonium will form pale blue precipitate. So do mention that adjective pale. And when you're in excess, it will give you a dark blue solution. So you must mention precipitate dissolves and forms a dark blue solution. The word dark must be mentioned. You can say dark blue or you can say deep blue. So now you can see that there is no clash. To To memorize this, you may pause the video here and go through this. This is the entire set of tests for cations. Now, one cation that is remaining is ammonium. So if you want to revise this, you can pause the video here and go through this, and otherwise you can proceed. And we'll see the next test for cations, which is ammonium. So if you have a solution and if you want to check if there is ammonium ion present in this time you add sodium hydroxide again. But sodium hydroxide will not form any precipitate because ammonium, like group 1s, also all the compounds of ammonium are water soluble. So this time what you do is that add sodium hydroxide and heat it. If ammonium is present here, it will release ammonia gas. Okay. And now we'll see bubbles here. Bubbles fizz. So then there must be ammonia. So to confirm that it's ammonia gas must be tested with the damp red litmus, which it will turn blue. Okay, so that's test for ammonium ion. So basically, what happens, chemistry that you should know here is that hydroxide ion will react with ammonium and displace ammonia from ammonium. So you get one of the product is ammonia, and the one H plus NH4 means NH3 is gone. So one H plus is remaining there. That H plus goes with this OH minus to form water. Okay. So that's why if any ammonium ion is there, you add sodium hydroxide or any hydroxide and heat. You need to heat this. Hydroxide will displace ammonia, take out ammonia from ammonium, and ammonia will be a pungent gas which will turn the damp red litmus paper blue. Okay, so these are the tests for all the tests for cations.